Hi everyone, in this video we'll cover EIP214 which introduced the opcode static call in EVM. So to understand this you should already know the basics of Solidity and Ethereum. If you don't know it or you need a quick refresher you can check out the other playlists on my channel. So in this video we'll cover the problem because of which Ethereum community came up with static call. We'll discuss the solution that is static call in detail. We'll discuss the benefits of static call and some use cases. And we'll also do a quick walkthrough of the EIP. So let's get started. A quick TLDR of static call. Static call is like a regular Ethereum call with one single exception that it reverts if a state change happens during the call. Also, it cannot be used to transfer Ether. To understand the problem behind static call, we'll take a scenario. Let's say you want data from some other smart contract and you make a call to that contract. Now, that contract may make further calls to another contract, or they might execute some other logic as well besides simply returning the data that you are asking for. So, this is a security nightmare. Take this example, we have three contracts: contract A, contract B, and contract C. So, if contract A calls contract B to get some data, contract B might call contract C further, or they might make a transfer to contract C, which might trigger the fallback function of contract C. And you don't know what kind of code they're executing because it might not be a trusted smart contract. Similarly, let's say you are executing the logic of contract A and somehow you trigger a send ether transfer call to contract C or maybe contract B, and it ends up executing the fallback function of either of these contracts. So again, you don't know what is happening there. Whereas your intention was just to read data from one of these contracts and use it in your own logic. So before static call, there was no restriction about what a call contract can do. As long as the computation can be performed with the amount of gas you have sent with your transaction, that transaction will execute. So, after making a regular transaction call or message call, unless you know the called contract and you trust the logic that is executing there, you cannot really make any assumptions about the state of contracts after your transaction has executed successfully. Now, this is a problem because since you don't know what these contracts are, and in most cases, you won't know what kind of logic they are executing, you cannot really trust them. And they can do some kind of malicious activities, like reentrancy is one of the major bugs that can happen in this scenario. To tackle this problem, EIP214 was introduced. So, this EIP adds a way to call other smart contracts and restrict what they can do. This way, it can be safely assumed that the state of all accounts is the same before and after the static call. This EIP adds a new opcode 0xFA that can be used to call other contracts or the same contract, and while executing that call, it prohibits any modifications to the blockchain state. This is applicable while executing any subcalls as well. If there's any opcode in the bytecode that attempts to perform a modification to the blockchain state, an exception is thrown instead of performing that modification. So at a lower level, this static call EIP introduces a new static flag to the EVM. This flag is set to false by default, and the value is always copied to the subcalls with an exception for the static call itself. So whenever you make a static call, it calls the child with the static flag set to true for the execution context of the child. Once this call returns, the flag is reset to false, that is the value before the call started executing. This is why its value is always copied to subcalls, but not for static call itself. So let's say you make a static call from your smart contract. For the execution of that call, static flag would be set to true. So the value won't be copied in the execution context of the child. But if you make any further calls in that context, the value true would get copied to other calls as well, so that you prohibit any modification of state in the entire call stack. So any attempts to make the state changing operations inside an execution instance where the static flag is set to true will result in an exception. Static call is almost same to normal call. There's one small difference that it takes only 6 arguments. The value argument is not included and it's by default taken to be 0 in static calls. Also, Solidity compiles the view functions that call any external contracts to use static call under the hood. You can check out the list of opcodes in evm.code's website, and here down below you will find the static call. So the opcode is FA, and here you can see the static call opcode. It takes in 6 parameters. You compare this with the call opcode, it takes 7 parameters where value is also there. So static call doesn't take the value argument, it sets it to 0 by default. And that's why you cannot transfer any ether using a static call. Because if you are transferring ether, you are by default making a state change in the account balances, irrespective of whether you are doing any other computation or not. So transferring ether is also prohibited. And that was in a way a major point behind static call, that you can prohibit contract draining exploits. So we'll understand this workflow with the example that we have taken earlier. Let's say contract A makes a static call to contract B. Now, in the execution context of contract B, the static variable or the static flag variable would be set to true. So if contract B or this function logic tries to make any kind of state changes, an exception would be thrown and the call would revert back with an exception. Similarly, if contract A makes a static call to contract B and then contract B makes any kind of normal call to contract C, this call from contract B to contract C would be a subcall. So in the execution environment, the static flag variable would be set to true, and if contract C tries to execute any kind of logic that changes the state of the blockchain, again the entire call stack would return back with an exception and that call would fail. So that's how by making a static call, you can be sure that you are not making any kind of state changes, or if you are calling another contract, they are not making any kind of state changes while executing that call. So coming to the benefits of static call, we have established that static call allows contracts to make calls that are clearly non-state changing. This has a huge benefit for developers and reviewers because it gives them an assurance that reentrancy bugs or any other kind of problems won't arise from that particular call. They can be assured that the call that they are making using static call would only read data from other smart contracts or other sources, and they'll not lead to any kind of state change. So any kind of mishap with the funds or draining of ether or any kind of tokens won't happen while making static call. So owing to static call, your contract can be a silent observer and read data from other smart contract without affecting their state or its own state. This is helpful in scenarios like fetching the current price from an Oracle contract or verifying certain conditions from other smart contracts, like if you are doing some kind of KYC or if you are doing some kind of credit scoring. So you are simply reading data from other smart contracts. And you wouldn't want any hacker to execute a malicious code and drain funds while you are making a call to simply read certain data. This is the official documentation for EIP214. It details a lot of things, and I have already covered most of the things from here. So do give it a read. It's short. You'll find some additional details here and there. For example, in the rationale section, you'll see that the community thought the static call would also make purely functional high level languages easier to implement. So you'll find some extra details here and there in the EIP, but the core concept behind static call I have covered in this video. Since view functions implement static call under the hood, you would have already implemented or used static call in one way or the other. So if you want to see how static call works, you can simply write a view function and try to modify the blockchain state while executing that function. You would definitely get an error. And that was all about the static call. Do check out videos on other EIPs and ERCs. Comment your doubts or leave feedback. Like, share, and subscribe. Thanks for watching, and I'll catch you in the next.